Okay, can you write this down now? Cantilevers and further support. Does anybody know this word, cantilever?
No.
No, are you sure? 1,000,000 points if you know it? No? No? No, I'll keep my 1,000,000 points, so... okay. Oh, sorry, did you write the title down? Yep. These are cantilevers. We have 3 types of cantilevers. This one's called the simple cantilever. This is not really realistic in real life because this is not it's just not good. Like it will easily break. This is more realistic. This is called a braced cantilever, and this is also a braced cantilever. But this one is braced from underneath, whereas this one is braced from above. This part that braces it is called a strut. This part that braces it is called a stay. So this is a strut, and this is a stay. And these are actually quite important. This one is not really. So, the definition, the problem is when the picture is so simple, it means the definition is so hard, because how do you explain something so simple as this? Oh, it's, a cantilever. It's like, how do you explain what a potato is? A potato is, a potato. Yeah. So, the definition is quite difficult because the picture is so simple. A cantilever is a rigid structural element. Now, let's just take this slowly. What's the meaning of the word rigid? Like strong, doesn't break. A structural element just means a engineering system, like a bridge or a house or whatever, such as a beam or a plate. These are called beams, wooden beams. Anchored at one end. What does the meaning of the word anchored? This verb to anchor. But yeah, hold still. Yeah. Anchored means like held at one end. Where do you know this word anchor? Maybe someone... Boats, yeah. So, you drop the anchor in the ocean to stop the boat from moving. So, it has the same meaning as, like, as you said, hold still or fixed. Anchored at one end, usually to a vertical wall, a vertical support, from which it's protruding. What's this word? Protruding. Does anybody know this word protruding? Yeah, sticking out from. What's most important, really, I think, are the pictures, because the pictures will help you remember what a cantilever is. So I also want you to draw these pictures, the 3 cantilevers. Do you draw the pictures? Yeah. Did you study this before, or who has seen cantilevers like this before? There is a cantilever somewhere outside Sylvia's office. As a game, I will let you find it. So look around Sylvia's office and you will see a cantilever system.
Outside the building?
No, inside the building, near Sylvia's office. I won't tell you. It's part of the game. You can find the cantilever system. And I won't tell you which type it is either. It's one of the three. Okay, continue? Not yet? Okay. What about now? Continue? Yep, okay. So, now that we have our definition, really it's just straight into an example of a cantilever. So this cantilever, I'll draw it for you. A 40 by 20 sign of 2 kg is hung by means of a braced cantilever. Okay, so we got a sign outside of a shop, basically. Let me try and draw it here. So here's our wall. And then we have this here. This here. That's like that. And the sign is 40 by 20. It's 2 kilograms. It's hung by a braced cantilever. The stay is 40 meters above the wall. Okay, so I'll just try and draw this sign here. Okay, this is 40 centimeters. This is 20 centimeters, and it's 2 kilograms. Okay. Well, I'm kind of complicating the picture. I don't want it hanging from two things. I want it stuck on. There, now that's a bit better. Okay, it's held by a stay, and the stay is 40 centimeters this way. And how long is this? This is 40 centimeters up the wall, and the other end is attached to the end of the cantilever. So this is attached to the end here like that. There, like that. Okay. Do I have everything in the picture? I think I do. What is the tension in the stay? So, let's draw the forces. There's one force here. We'll call this T. There's another force here from the weight, which is acting straight down, pulling down on it. So, I'll just draw it here, it's pulling straight down because of the weight of the sign. And this will be a 2G that we know. But there is one more force I did not draw yet. And what force is that? Yeah? Which one? Say again? Reaction where? You're right. There's a reaction force I didn't draw. But where do I draw it? On the wall. Here? Or, well, doesn't matter. Here. Now, big question. Which way is this pointing? This way? Nice try, but only half right. That's it. This way? Not right. Like this? Not right. Sideways, yeah. Yeah, you got it. It's actually this way. Now you might say, why is it this way? Well, this is doing two jobs, okay? The first job is it's actually stopping the sign from falling. So there's a force here. The second job it's doing is like when I push against the wall, it's pushing back. So there's actually a force this way. So together, in total, it makes one force that way, which we can consider as two forces if you like, an or X and an or y, if you would like to. Okay. So let's begin. Part A is find the t. Now what would be the best equation to find the t? You actually have three equations. Up equals down, left equals right, clockwise equals anti-clockwise. What would be the best one to give me the t? Let's see, what do you think? Up equals down? No. Because the problem with that is it will have an or and a t in it. And actually, from looking at this, there is a way to do this with just one equation. Can give you the t. What do you think? Well, I tell you, what you can do is, you can say the turning forces are equal, okay? But, here's the key thing. We take this as the turning point. Now, why might I take this as the turning point? What's a good reason to use this as the turning point? Yeah, but I mean to say, remember we can put the turning point anywhere. So why might I choose this as the turning point for my calculation? What's the advantage to me? So I don't have to calculate the or, because I don't know the or. But now I don't need to know the or. Okay, so this one, clockwise or anti-clockwise? Clockwise, and this one? Anti. But remember, it's perpendicular that we care about. So I do not care about this, t cos theta, and that's theta. I only care about this one, which is t sine theta. So I have 0.2 times 2g should equal 0.4 times t sine theta. Can you see that? That this force by this distance should equal this force by this distance. Just like with the examples we did today. Now, there's one tiny problem with this. What's the small problem with this equation? Two unknowns. Yeah, what are the two unknowns? Well, this is okay because I want to know this, but we don't know the theta. We actually can know the theta. Let me just draw the triangle. Do we know this length? We do. I said it's 40 centimeters. Do we know this length? We do. I said it's 40 centimeters. So you can get this length here by just doing tan inverse 40 over 40, which will be 45 degrees. What is sine 45 degrees? Root 2 over 2 or 1 over root 2 if you hit it in on the calculator. Yeah. 0.4 g equals 0.4 over root 2 t. So t is, oh nice, cancel g root 2. What's that, about 14 newtons or something? Yeah, 13.87. Problem? Is that a yes or a no problem? Good, bad? Continue. There's another part here. What is the horizontal reaction force? Okay, who's got an idea on how to get this one? Or X? Yes? Very good. Because the right equals the left, you can say this equals t cos theta, which equals 13.87 cos 45. Cos 45 is 1 over root 2. So, do I still have it here? I do. 9.81 is the answer here. Part C, what is the vertical reaction? Okay, who has any bright ideas for getting the one here, the or y? How could I get that? Yeah? No, nearly. Or y, I think you mean say or y plus t sine theta equals 2g. This and this should equal this. What formula is that?
Up and down.
Up equals down, yeah. So we get or y equals 2 times 9.81 minus 13.87 times 1 over root 2. See what we get here. .81 roughly for this one here. Yeah? D. What is the magnitude of the reaction force at the hinge? In other words, what is the OR? Now, how can we get the OR here? Any ideas? Yeah? Pythagoras, very good. So the OR will equal square root the OR x squared plus the OR y squared. So when you calculate that, you'll get, I think you'll get 13.87. Coincidentally, the same number as this. Okay, and E, lastly, what is the direction? What is the angle? So how can I get the angle here? Yeah, tan inverse the y over the x. The tan inverse or y over the or x. And when you put in the numbers, that will work out to be 45 degrees.
Can't we just guess it's 45 degrees?
It's not always going to be the same actually. In this question here, it's going to be the same. But I'll give you an example here. The reason I think this works out that this equals this is because this is 45 and it kind of makes a nice sort of symmetric image. But if I was to do something like put an extra weight at the end here, like an extra say 5g weight at the end, then you kind of break this symmetry. The picture is not balanced. So this angle then would not equal this angle anymore because of this weight. So just for my first example, I kept it easy. In the exam, they sometimes hang an extra weight at the end. What would be the effect of putting the extra weight here? Well, not too much. It just means you have to take this away. You would, like for example, if you had a 5g at the end, you would have to say this plus this equals this plus this. You know, it just adds an extra element. It's not really a big deal. But it's enough to change the angle then. Okay, so can you write this one down? It's getting a bit harder now.
So the reaction force is actually the development.
What do you mean exactly?
Question E was asking for the magnitude of the reaction.
Yeah, yeah. How big is the actual resulted reaction force at the hinge?
Oh, it's not the up and the gravity, the weight and.
Oh, it's not. No, it's not the net force. It's the reaction provided by the hinge. In other words, it's like the hinge and the stay are working together to hold the thing up. I'm asking how much each one is doing. You know, like what force each one is providing to support the cantilever. Got this? Yep. Okay. No, I still see a person writing. Which part are you at now? Okay. Yeah, E is the angle of the reaction force at the hinge. That angle, yeah, it's like there's the hinge, there's the beam, there's the wall, and this angle here is 45 degrees, and this is 9.81 newtons.
What means 100 over -1?
Ah, this?
Yeah.
Is this new for you?
Yeah.
What high school did you go to? What system? American?
I don't know.
Korean?
Yeah.
Maybe in Korea you write it like this. Or maybe even like this. No, not cotangent actually, that's different. Do you know this one or this one?
No.
No. And you don't know this one?
I think that is the cotangent X.
Not cotangent. Oh, yeah, no, not cotangent. It's not cotangent X. It is what's called the tan inverse. Let me give you an example. Tan 45 degrees equals 1. So, tan inverse 1 equals 45 degrees. This is used to find angles. Yeah. So it's tan inverse the opposite over the adjacent. You know, in the triangle. If you want this angle, it's tan inverse O over A. That gives you this angle. Is this new for you? I think you'll do this in maths class. What lesson are you on in maths at the moment? What was the last one you did?
Set notation.
I just remember this thing. Like one meter and the one is
Inequalities. Okay, I don't think you'll do the trigonometry until maybe after the break. You will study this in more detail in math class, and if you want to watch the video, we talked about this a little bit in this lesson. Right. Yeah, you see, to find this we use the tan inverse. So tan inverse this over this. Yeah. You can watch this video, number 5, is the answer for this one. Did you watch the video? Oh, you did? You did watch it? And it's confusing? We can do this on Friday if you want.
Friday.
Yeah, if you want, I can do this in the tutorial on Friday.
Yeah.
Just ask me.
Yes, what is this then? You mean this is anger?
Correct.
But well, this is
No, it's not. It's wrong. Yeah, it is, believe it or not. I know that this equals this.
yeah.
But when I write it here, it does not mean that. It has a different meaning.
It's different meaning.
Yeah. Yeah. It's confusing, I know.
Why you're thinking
Okay. Here's another example. A 13 kilogram ladder of length 13 meters is up against the wall, and its foot is 5 meters from the foot of the wall. The wall is smooth, not smoother, and the ground, where's my N? The ground is rough. Grout. What is the angle? Okay. Yeah, no, that's a typo. I should say smooth, not smoother. Okay. Here is the ground. And then here is the wall. Now, this wall is smooth. And this ground is rough. What that means is the ground, there's friction, but on the wall it's smooth. Okay? The ladder is 13 meters and also 13 kilograms. And this side is 5 meters. So, if that's a 5 and that's a 13, using our friend Pythagoras, how much is this side?
2 ergo.
2 what?
12.
12 meters. Great. So 5, 12 and 13. And here is one force. This one is 13G. Now what force do I have here? I have 2 forces. I have a reaction and also a friction. And here what do I have? Reaction, which way? It's actually just out. Yeah.
And down.
No, because it's smooth. There is no friction vertically. It's only pushing out. It's not holding it vertically. Okay? So these are all the forces. This is all the forces. Right, what's my question? What is the angle of the total reaction, including the friction, at the foot? In other words, these two together make one force here, and I want to know this angle. Okay, so if I want to know this angle, then I need to know what this and this is. So which is easier to find first? Should I try and find the F or the R? What looks easier? Or do I need to find the S first? Let's see what equations I can make. So I can say or equals 13G. Oh, that's it. Yes, or equals 13G. I can also say F equals S. Alright, last one. Where should I put the turn-in point?
S.
No. Yes.
R.
Yes, why? Why should I put it here?
Easy.
Yeah, why is it easy?
R.
Cancels what?
R.
Cancels or and F. Okay. Clockwise or anti-clockwise? This one. Anti. This one? Clock. Okay, so firstly, let's do this one. What is the force? 13G. And what is the distance? What is the distance here to here?
Oh. 13 over 2.
No.
Why?
Yeah, why? Someone tell them why. Why is it not 13 over 2? Why is it not 6.5? He's saying 6.5. It's not this.
Is it 13?
And it's not 13. Oh, the total length is 13, yeah.
Which length is it?
Well, I'm not telling you. I want to see if you can tell me. I want the turning force provided by this one. So the force is 13, but what's the distance from here to here? It is, anybody? 2.5. Because remember, it's not the distance, but rather the perpendicular distance. It's this distance. Remember this? But what?
But from the middle one, what if you draw a line like this to make it perpendicular?
If you go this way, then what you have is a pain, because then you have to resolve this and use this. I don't want to do that. Rather, I will keep this, but instead use this distance, because that's the perpendicular distance. That should equal, now be careful, S times what distance for this one? I told you to be careful, it's not 5. What distance do I multiply my S by?
12.
You don't sound certain.
No.
It is 12. Yeah, because look, this is the force, yes? And the distance is from here to here, the perpendicular distance. Yeah? You can see that? You don't see that? You know, the definition is, remember, the turning force is the perpendicular force by the distance. So for example, if it's like this, this is the force, this is the distance. I don't use the F. What do I use? I use Fy. So I can use dFy. You're happy with that? Right. But I said there is another way to do it. If I want to use the F, then instead I use this distance, which I'll call d perpendicular. So I could then say I can use F dy or d perpendicular F. I had two ways to do this. I said most of the time it's easiest to use this. But here is an example, and it doesn't happen often, but here is an example of when it's actually easier to use that. So 90% of the time this is the best one to use, but sometimes this is actually better to use. You're so unhappy. So unhappy. Is it okay or not okay?
I understand this part, but I don't understand it.
In the picture. Okay, so let's go to the picture now. And let me just draw it again here. So wall, floor, ladder, turning point. This is the force, yes? This is the distance. So I could do this. I could say, okay, Fy, Fx, and then say it's dFy, this being Fy and this being Fx. Or, if I want to use this F, then I need to use this distance. And this distance is 12. So many.
Okay, here you use the percent of but in the F, you use the thousand.
In which one?
What is the F part?
Which part are we talking about? The previous one? Oh, the 2.5. No, this is the perpendicular because the force is going down and this is the turning point. So this is the distance, the perpendicular distance to it, yeah. Not easy. Not easy. Can I continue? No. What question do we have now? Well, look, we've done the hard part. This is the hard part. Now we have to solve. So F equals S. I can get the S, can't I? So let's get the S. 13 times 9.81 times 2.5 divided by 12. The S is 26.57 newtons. So the F is 26.57 newtons, and the ore is 13 G. 127.53 is 13 G. Is this a nod of yes, I understand, or this is a nod of no, I don't understand?
What happens to the RY, SY,
I never needed to consider it. I approached this question by looking at perpendicular distances instead of perpendicular forces. It was more convenient to me. So, in fact, I did not need to know the RX, the RY, the SX, and the SY. I was able to use their perpendicular distances instead. So, if I draw the triangle here, this is the F, this is the OR, for here, and I want to know what is this angle. So the answer is theta is equal to tan inverse 127.53 over 26.57, which equals 78.23 degrees. That's the answer. That's the theta. Students find this lesson hard. Yeah.
makes sense.
Or perpendicular force multiply distance. You can do it this way, or you can do it this way. That's what I was trying to explain over here. You actually have two ways to do it. Most of the time, this is the best way to do it. But today, we can see that sometimes it's better to use the perpendicular distance. Yeah? Yes. That should say smooth, and that should say ground. Oh, you look so unhappy. You're like, it's like I'm punishing you or something.
No, I was asking something about the question.
Which one's that?
The
The previous one?
Yeah.
This one?
Yeah.
Yeah.
Here, the A.
The A.
Yeah. You said sin 45 is 1 over root 2.
Yeah, or root 2 over 2. Same number.
Yeah, but when you multiply it by 0.4, you get root 2 over 5.
Sine 45 is 1 over root 2. This is the same thing as root 2 over 2. I hope, yeah. I'm pretty sure it is. Both of these are equal to about 0.7.
Okay, if you multiply that by 0.4.
Which one?
The 1 over root 2.
Oh yeah, okay. Or are you saying I have a mistake in my multiplication somewhere? Oh, okay, but I actually cancelled the 0.4 on both sides. You see, there was a 0.4 here and a 0.4 here, so I cancelled it. So I actually never multiplied it by 0.4, because I was able to cancel it on both sides. You put in, you left in the 0.4, was it?
No, but I got it.
Okay, are you sure?
I hope so.
Okay. Do you need to write this down now, or what?
Yes.
Can you write this down? Make sure you have this.
The weight is 13 kg, right?
Yes. Oh, come on, what? It's not that bad, is it?
Oh, down.
Now, come on, if we talk like this, you'll want to go back to biology. We can't lose them after one day. Left equals right, up equals down, clockwise equals anti-clockwise. Yeah. So this one here is up equals down, left equals right, and clockwise equals anti-clockwise, using this as the turning point.
So the reaction force from the wall of C.
No, I only wrote, no, it's S. I'm sorry, I wrote C just to show us is a clockwise one.
Oh.
The C is actually short just for clockwise, like the A was short for anti-clockwise. No, the force here is S. S. It's hard to tell from your faces if you're understanding this or not. Can't quite tell. I can see you're all unhappy. But what I care about is not if you're unhappy, but if you understand this.
I understand this now. I understand.
At this exact moment you understand it, but I can feel you're worried that the moment you go home, you won't understand it yet. Well, look, we have the tutorial tomorrow. So I feel like you might want me to do some of these tomorrow. Okay, so tonight, can you try your best to do these questions? And the ones you have trouble with, we'll have a look at them in the tutorial tomorrow, okay? I don't know, we had a couple of hard lessons lately. How did the lesson, the central gravity lesson should be fine, I think. But what about the rocket lesson? Have we tried that yet? The rocket one?
Oh, sorry.
Hard, isn't it?
Those chapters
Yeah.
ask you, yes, that's very much.
And what about this
This one should
one?
be okay. This one should be okay.
Yeah.
This one I know.
Is this one a hard one? That's why I have a star. Yeah.
Any questions?
Guys, I think I have a feeling that I won't get a chance to answer all the questions from this week tomorrow. So if there's any questions we don't do tomorrow that you want me to do, we'll just do it next week, because I don't know if next week is as hard as this week. That's okay. That's easy. That's easy. That's easy. That's easy. The lessons next week are actually, looking in the book, are quite easy. So for the tutorial next week, you shouldn't have many questions. So we can just answer questions that you have from this week as well. Do you know what I mean?
We got tomorrow 45.
Yes.
And the one.
And yeah, correct. Yeah. Yeah.
I'm curious, when are you going to upload this video to your YouTube?
Today.
Today?
I'll do it today. The lessons. Let me see. Hang on. Yeah, right now I'm uploading the lessons that we did recently. So right now rocket science is being uploaded to YouTube. It takes a while to upload the videos. I think later today they should all be finished uploading, including the lesson this morning. So you can watch it later if you want. Okay.